latest few years, we've changed that to generic automation framework because it can be used also for other automation. Test automation is where it came from, and it's still very important, but you can also use it for other kind of like process automation, RPA, and stuff like this.
That is Pekka Clark, founder of the Robot Framework and currently the lead developer for the Robot Framework Foundation. I'm Josh Burke, your host for the Salesforce Developer Podcast, where you'll hear stories and insights from developers for developers. Today on the show, we sit down and talk with Pekka about the framework, which has its origins as his master's thesis.
Still about the thesis, so the original idea was that I wanted to study that what kind of common components we could implement. So when implementing automation frameworks, we didn't need to build everything from scratch, that maybe we could use some kind of a common logger or something like this. But the major finding in the thesis was that it's actually possible to create a generic framework so that you don't need to have only components that you use to build your kind of core framework, but we can actually create a generic framework as well. And that was kind of it wasn't yet part of the thesis prototypes, but that was kind of finding based on the prototypes. Okay, this would be possible. And I had those ideas then when a colleague of mine with whom I had been working in an earlier automation project had joined Nokia. And they needed automation solution for a very heterogeneous environment and contacted me, okay, what do I have any ideas? And I said, well, yeah, I have much better ideas than we had earlier. And went there, presented what I had been studying, ideas I had, and they liked it. And we started developing the framework there in 2005, I think, some autumn, 15 years ago or so, something like this.
Yeah. Interesting. So your thesis was kind of the prototype for the robot framework, and then Nokia kind of gave you the ability to start putting it into real practice?
Exactly. Yeah. So I had, when I was writing the thesis, I had ideas that, okay, this would make sense as an open source framework as well. But when we started Nokia, it was for internal usage only. But I, from the beginning, wanted even there keep the core generic and then extend it with the customer libraries in different kind of product lines and so on. And then this colleague of mine who got me there also fought with lawyers, and we got the permission to open source it in 2008. So it's been also available as open source over a decade now.
Gotcha. And so, okay, so then the original intent was always for it to be open source. Why was that important to you?
I got a feeling that this kind of framework that we have, which can be extended with libraries and so on, works better as an open source solution, so that everybody can contribute and to the wider ecosystem. Of course, people can contribute to paid solution as well, but that's kind of less likely. Also, of course, I had these ideas. I thought they would make sense, but I didn't have resources or anything to start starting a product company. I wasn't sure would that fly. Also, if I would have started a product company, I would have ended up thinking about like how to handle licensing and stuff like that, which I wouldn't have enjoyed. I was interested to get this framework working, and that way open source was good. Also, I've been most of the time when writing the framework, I've been paid by Nokia and then by the Robot Framework Foundation nowadays. So it has been kind of that way safer. And I like most open source ideas. I don't have anything against paid software either, but I think in this case, having the core available as open source is better for the wider usage. Maybe I have that kind of thinking that I want to make the world a bit better place in this regard. Well, doesn't really stop the wars in the world or doesn't save the people from hunger or anything, but at least it hopefully helps people doing testing to make their automation efforts a bit easier.
And tell me about the Robot Framework Foundation. How did that come to be, and what's the current state of it?
Oh, yeah, good question. So Nokia was sponsoring the development for a long time, but it was kind of becoming evident that they are not going to do that forever because it's not their core business, and the framework started to be good enough for their usage. And there's always managers are changing and priorities are changing, so there's always kind of a risk that it might be discontinued. And around 2014, I think 15, something like that, companies in Finland that were using it a lot, like consulting companies selling services related to framework and so on, they kind of started a bit worried that what happens if this Nokia sponsorship would end, and then a foundation was formed to support the development. And kind of incidentally, it was like half a year after the foundation was was founded, then the Nokia sponsorship did end. So it was about the right time. And
Nice.
the idea of the foundation is that it collects money from foundation members, of course. Nowadays, we've also got some money from conferences. We've organized Robocon conference 3 times, and we are planning to have an online conference in the future. So that way, we collect money and then spend the money for paying developers, developing the framework, and also some libraries and tools around the core framework.
Gotcha.
So the idea there is that it's a non-profit, but making sure that the framework is there, that it's developed further.
Got it. I want to follow up on that, but I think that's also a really interesting point that the importance of this being open source is also the fact that like for instance, I know internally at Salesforce, especially over at the .org side, we use a lot of the robot framework, and it's like, even if you stop developing on it, the foundation kind of make sure that it's going to continue on in some form that somebody could continue using and not have to basically completely upend their automation framework.
Yeah, exactly. So that's first of all one of the benefits of open source in general, that you know that nobody's going to take the code away from you. That even if the developers stop developing it further and so on, you still have the code. You can use it freely, and you can develop it. You can develop it further, either internally or resurrect the project publicly or whatever,
right?
If you want to. So that's really nice. But also with the foundation, the good thing is that there's this kind of backing. It's not that I'd be working on this without pay, which would be not maybe so motivating all the time. I then needed to have another job to pay my bills and
right.
So on. Or if something happens to me, be it the buzz factor or just kind of a burnout or bad motivation loss or whatever, then there's always the foundation there to take care of somehow. So that's all. That makes it also safer to adapt to.
Okay, so we've talked a lot about how framework came to be and how it grew into open source, but let's get into more details about the framework itself. And I think you've touched on this a little bit about some of the key components of the thesis, but let's start with the elevator pitch. What's the elevator pitch for the robot framework?
Yeah, so it's a generic automation framework. Very quickly, that's what it is. So it's a generic automation framework. But
gotcha.
if I tear it down, generic basically means that you can use it basically with any interfaces and so on. Not the core framework only. You need always libraries. So that's the architecture there. You have the core framework that handles parsing data and executing test cases and creating logs and reports. But then to interact with systems, then you need libraries that you have a lot of ready-made libraries available, but you can also very easily create your own. So that's what generic means. Automation framework here means that it's not only a test automation framework. So we used to actually call it like a generic test automation framework, but latest few years we've changed that to generic automation framework because it can be used also for other automation. Test automation is where it came from, and it's still very important, but you can also use it for other kind of like process automation, RPA and stuff like this. So not only test automation. And framework, well, it also means this that we have libraries and so on. So it's not a kind of one solution that you just take this and then it solves everything, but you basically take the core framework and then you have libraries that you need, maybe some ready-made ones, maybe some you create yourself. You then have external tools, editors, you have editors and editor plugins, you have maybe continuous integration and so on. So from those components, then you build your kind of higher level framework that you then use.
Gotcha. So that's interesting. So it kind of resides adjacent to X, and X could be Cumulus, or X could be Jenkins, or X could be Selenium, and you're just kind of providing the tools to interact with that and have processes move things down the chain, so to speak.
Yeah. Typically it works so that there's a CI then could be controlling robot framework. So you have CI system that launches it maybe based on an event that we got the new code committed, or maybe it's a scheduled run, something like this, and then the framework is called, but then it can use internally tools like Selenium or Playwright, or well, if you're doing web testing, but then other tools if you're doing something else like UI testing or REST API testing or database testing or whatever, and so on. So that's kind of libraries are kind of in a sense below this framework, but then there are these CI systems and whatever pipelines then kind of above it. And that whole thing then, with whatever you need. Maybe you need and want containers, you have those. And that's all of that is what makes your final automation framework. And it's definitely not the same in different projects because the project needs are different. And this framework tries to be very open in a way that how you can use it. So it's very easy to adapt. So that's a strength, but also, of course, it's kind of, when you start using it for the first time, it can be a problem. There's some kind of a learning curve because there's no ready-made way that, okay, you always do it like this, because how you want to adapt it, how you want to utilize it depends on your context and your needs and so on.
Got it. So it's not like, for instance, I'm thinking of my early days with like Jenkins, where it's like you basically just install it and then you go find somebody else's bash script and then you rewrite the bash script a little bit and you're kind of done. It's a little bit more flexible, but also more amorphous because of the way it's designed.
Yeah. Well, Jenkins is also, it's a CI tool, not like automation tool. I think if you would compare it, for example, with commercial automation tool that would be dedicated, for example, only for Windows, web testing and Windows UI testing, then when you buy it and install it, you have a ready-made package that covers that, and that's it. But then if you want to, if that's what you need, then that can be nice. But if you then need something else, like, okay, you need REST API, so you need database or something, it can be then more complicated. But with this framework, you need to basically select what you need. It also means that in bigger projects, that at least there are kind of different kind of users. There are those users who are setting up the environment and making decisions at what libraries we use, maybe creating their own library, setting up guidelines and so on. And they need to, of course, know the framework very well. But then for the end user, when everything this is set up, it should be pretty straightforward and simple to create those test cases because the language that you use is pretty simple.
Nice. And what languages does it support?
Robot Framework itself is implemented using Python. I guess we got somewhat lucky with that when it was not that widely used. Back when I started writing Robot Framework prototypes, I actually, when I was writing my thesis, didn't before that really know Python even. It was just seemed like a cool language because I had experience with Perl, but I felt it was a bit like maybe too magic, but I like the fact that it's scripting language and it's easy to make prototypes. So I picked up Python to learn it as well. And it's been over the years been getting more and more popular all the time. So that's good for us. So yeah, the framework is implemented with Python, and that's most of the time also what you use when you extend the framework with those custom libraries or with other kind of tools. It runs also on Jython, which is a Java implementation of Python, and then you can create libraries using Java, but that's not anymore. Maybe it's not going to be that relevant anymore because unfortunately, Jython doesn't support Python 3 syntax, and we are relatively soon going to drop Python 2 support because Python 2 is not even, has reached its end of life. So it's not, Python 2 is not supported, and we are not going to support it too much longer. Our next major release will still support it mainly due to Jython. But the idea was anyway that it was very important back then during the Nokia days, especially to be able to use Robot Framework on the JVM. But yeah, Python is what you mostly use. But then when writing libraries, we have so-called remote library interface that allows you to use to basically any language you want. We have some remote server implementation ready-made, but you can also create your own if needed. So that allows you to create libraries using other languages as well. Also from Python, you can call other languages depending on the case. So that might be a way. And then if you are, for example, implementing a tool for processing results, then results you get them in XML. So you can use any language, of course, and process it with the XML and do something with the information. Doesn't need to be Python.
Gotcha. Nice. So that kind of speaks to, so it's very flexible in what it can also talk to. If I have like a node script that's running some part of my build process, my node script could still talk to the robot framework.
Yeah, you can run those scripts as processes. That's one simple way. If that's kind of a script that you can run from the command line, you just execute as a process. Or then if it has ready-made function that like you can use as kind of individual keywords, then maybe you expose that as a remote via the remote interface or something like this. But there's typically always a way. The way is, of course, depends on the case.
on the specific, sure.
Yeah.
Now, describe what it means for it to be a keyword-driven approach.
Good question. So, keyword-driven approach for test automation means that basically you construct your test cases or tasks if you're doing other kind of automation than testing. You construct them from keywords that are also, some terminology calls them action words or something. So they do something. You have a name and basically that's a string, and then you call that and you can give it arguments. Maybe keyword can also return you something and so on. So that's how you do it. You could have a keyword like click button, and then that obviously clicks a button, and you are going to give it the ID or some other locator of the button to click and so on. And then, then the keyword clicks a button, and if it, for example, doesn't find that button to click, then it probably fails, raises an exception, and is considered failed. Or you could also have a keyword like button should exist that is going to do a validation. Do you have a button or not? And if you do, then it just passes and everything is fine. And if you don't have that button, then it will fail. So that's how you construct those test cases. You basically build them from keywords. And these keywords with Robot Framework, they come basically from two different places. We have libraries that are implementing most of the time using Python, as we just discussed. So they can implement keywords. If you would have, for example, that click button keyword, it basically would be just a Python method or function with that name. Maybe like click button with all lowercase and separated with underscore or something like this. So that's how it would be, just like a regular Python function. And then you take the library into use, and then robot knows that you have this kind of keyword and you can call it. And then if the keyword raises an exception, the framework considers that keyword failed and otherwise it's passed. So that all the keywords that actually do something concrete, they always come from libraries. But one of the really powerful features of Robot Framework, one of the features that was actually described already in my thesis, is that you can construct your own like higher level keywords using more or less the same syntax that you use for creating test cases as well. So you construct test cases from keywords, but you can also create new keywords from keywords, and then you can use those keywords in your test case, which means that you can have whatever abstraction layers you want. You can have free domain-specific language, even though you were using ready-made libraries that are not created by you, that could be very low level. You can still create your test cases using domain-specific language that is then constructed from your own higher-level keywords, what we call often also user keywords, that then call other user keywords, perhaps, or library keywords, and so on. So you have like keywords or keywords everywhere. And then in the end, then always the lowest level keyword is from a library, and then that's actually going to do something concrete, like clicking the button.
And I think it's interesting. So Robot Framework got on my radar with a conversation that happened on Twitter where Jason Lance, former podcast, and does crazy mad science stuff with build process and Salesforce.org. And so he was actually showing me this in action on our side of it earlier this week. And what was really cool was how that layer of abstraction that you're talking about solved a huge problem when it comes to UI testing, because especially the Salesforce UI changes all the time. And so when you're talking about that click button event, well, maybe some designer, slapped a different design class onto that button, and now that test is going to fail because Selenium doesn't know where to find that button. But Jason's like, but it's just a keyword. Like I change it once, and then I just expose it as click button in all of my other tests, and then we just push out an update, and we're done and we're good. Is that a common design pattern that people use with the Robot Framework?
Yeah, obviously, yeah, it is. So that those higher level keywords, they definitely, as you just said, they allow you to, they enable better maintenance so that you can have, for example, those button IDs or whatever locators inside those keywords, and you use them. If you want to click certain button, you don't use that ID in any other place than in that kind of high level keyword. It also helps that you can, your test cases then are much more readable on top level when you can have like keywords that are like sentences, like log into system or something like this, instead of saying click button and then some strange looking XPath expression, for example, that would click a button or whatever. So you can abstract things away, you can hide details, and then also get better maintenance support with these keywords. Yeah, so that doesn't mean that you always need to do that. You don't always need to write your these in high-level keywords.
Okay.
Especially if people were using the framework are programmers, they might be annoyed that they need to create these high-level keywords in robot framework syntax, which is, of course, inferior programming language compared to, for example, Python. It's this description language that has certain kind of programming capabilities, but if you need to do real programming, you go to library side. So you can have also all your keywords in libraries. So that's totally possible as well. So that your library keywords can also have describing names. They can even have like a non-word characters and so on via decorators and so on. So you can freely create keywords in libraries as well if you don't want to use Robot Framework for anything else than describing your test case and then have everything else in Python. But how you do that is totally depends on the team. So if everybody is a Python programmer, that might be a great way because then it's easier. They can be in Python most of the time. They just describe those tests in high-level language that is easier than for managers and that kind of stakeholders to read. But then if you have non-technical people who are also participating in automation, they can then utilize this other approach. They can create their own keywords in Robot Framework language, which is, as I said, it's not as powerful as Python, but it's also much easier to use for simple cases. So it's easy to easy to start doing this kind of automation. We actually do our own keywords, even if you aren't a programmer. And then maybe in the long run you learn a bit more, and then you can actually even start looking at the Python side, and then you become a programmer.
I mean, first of all, I got to say, Python is actually one of my favorite languages. We also share a little bit of history because my first, and this is totally going, we're twice aging ourselves because we're both Commodore 64 kids. And also, my first work with intranets was using CGI with Perl-based CGI. And so I'm like, and every now and then I just like to kind of throw it to developers. And any Perl developers still out there, and we're a slowly dying breed, unfortunately.
Yeah, well, it was back when I was doing Perl. I think I had earlier at that time when I learned Perl, I had been writing some Java at school, and that was so verbose and like stuff like open file. Well, we are not talking about like just Java 1.2 or something like that required opening so many readers and whatever. When in Perl it was like open or die or what was the idiom to do it, and it was like this is so easy. So that why it was easy to write. To get started with writing automation code with that, but then I also at some point realized, okay, this is not when I need to have some kind of bigger project. I may want to have object-oriented features, and they were pretty good in Java compared to Perl. And then Python for me was kind of a really nice middle ground with objects and features that can allow you to create maintainable program, but also then easy to open files and do stuff like this that is important when you are implementing automation solutions. Of course, Java has got much better since that as well. So, but yeah, this shows our age, I guess.
Just a little bit. But one of the things I love about Python is I think Python might be one of the hands down most readable languages on the planet. And when Jason was showing me like his test scripts, it really reflected what you were talking about before, where it's like, this is so human readable. Like it's like log in, click this, click button, enter text. It's like very, very straightforward and just getting the job done. Was that like a design goal of the robot framework, or did you just kind of get that for free because of the readability of Python, or a little bit of both?
How robot framework test data looks like, it isn't that much infected on how Python looks like, because of course we could have implemented same kind of keywords and so on using Java. And well, actually still nowadays you can use Java-based libraries as well. Yeah. But you're right that Python itself is very readable. But still, if you're not a programmer, it's not that readable. Unless, of course, if you try to make it so that you really, really make sure that your top level, like a test case in Python, if you were implementing in Python, would have really high level internal kind of method names, and it would be calling helper functions. So you may be able to write something, but still for casual people who are not programmers, then all those not using an underscore, not a space to separate words and colons and parents and whatever. They are just kind of a distraction. And also with Python, although it's quite easy to read, then and to some extent also easy to edit, but then there's this indentation that is pretty strict, and if you are not aware of that, you will get just strange errors and so on. So the idea with Robot Framework is that it's still kind of higher level and something that you should be able to understand. Of course, it depends on how good your test case is in general, but it should be easy to understand what the test case is doing just by reading it, if the test has been done somewhat well.
Yeah, I have to confess, my first foray into Python was writing a module for a search engine, and I shook my fist at the screen for probably a good 2, maybe even 3 hours, wondering why my code wasn't working correctly, and I realized it was because I was indenting it the way I wanted it to, not the way Python insisted that it have.
Yeah. Yeah, that you kind of need to do it like Python wants it to do, otherwise it won't run.
Right. Like it's very readable, but because it has its own set of rules that are not negotiable, and you have to follow by Python rules in order to get to work, which is another thing I kind of like about it.
Colleagues who find it totally. Yeah, I've had colleagues who really didn't just want to use Python at all because it was forcing them to use some kind of indentation. But yeah.
Yeah,
it doesn't bother me at all.
Gotcha.
The great thing is that it's quite hard to make total mess with Python code because at least the indentation you cannot miss if you want the code to work.
And it kind of removes like that opinionated. I'm going to put my function statement like this because I feel that's like Python's like, no, you don't get an opinion. Like my opinion is what's going to happen here.
But of course, then you still have like how many spaces are you going to use? Are you going to use spaces or tabs? And are you going to have empty lines here, where, and all this kind of
exactly.
kind of fights?
Yeah. So. Okay, so on the framework itself, are there any features or anything on the roadmap coming up? You were talking about moving to Python 3. Anything in the future of Robot Framework that you want to give a shout out to?
Well, we are just now developing Robot Framework 4, which is going to be a really, really big release with feature-wise. It's going to have, for example, long-awaited skip status. So that's one thing that you now can do, that you can skip a test case. Otherwise, already it was either pass or fail. And then we had our kind of custom criticality concept that allowed you to, among other things, emulate the skip functionality. But now we are going to get the real skip thing in. So that's going to be big. It's going to have some enhancements related to type conversion that we do with arguments.
Okay.
It's going to have some enhancements to library documentation related to the features, both to create the HTML documentation that we can generate for libraries. That's going to be better, and also we are going to create better so-called spec files for editors and other tools to use.
Okay.
It's going to also have enhancement that hopefully make it easier to create better debuggers in the future. We have so-called listener API that gets notifications during execution, and there are certain important enhancements coming to that. And finally, we just today made the decision that we try to squeeze native if-else structures into this release. They were planned for the next major release, but there's quite a lot of demand for them, so we try to get them into as well. So nowadays, when you create keywords with tests with robot, you basically construct them from keywords, but then there are keywords like run keyword if that can execute things conditionally.
Gotcha.
But now we are going to add this native if-else structure to robot framework syntax itself, so that you can do things conditional. If something happened, you do something, and in other cases, you do something else. That's especially important in this kind of business process automation. So there are needs for that also in test automation, but in RPA and so on, then that's much more high priority.
Got it.
So yeah, that kind of stuff is coming in, so it's going to be a really interesting and big release.
Cool.
We just got an alpha out this week with skip status, and hopefully we'll get an alpha 2 out quite soon as well.
Cool.
Going to be also some backwards incompatible changes there for do the skip status, for example, and that's the reason why we want to have early alpha so that everybody can adapt.
So you had mentioned earlier that the pandemic had affected the conference cycle, which is happening to everybody. Has it affected development at all?
Not that much directly. We had since the Nokia days where kind of we've had anyway pretty distributed way of working, so not a team that is working in the same place. So we're working via GitHub, producing pull requests and so on. Now we actually have a bit bigger team as well. Which is nice that we have more people working with this release than just me. Many of these are actually some of these are physically pretty close situated to me, but due to COVID, it's not maybe the best idea to meet that much. So that's kind of annoying.
Gotcha.
But they're also like René from Germany, and so we wouldn't be meeting face to face that much anyway. Probably we would at some point. So it hasn't that much affected. But of course, this that we cannot organize the conference now in January means that we are not going to get money from that, and that's kind of a problem for the next year. But we'll see how well the online edition works. I hope when we get more information about it, we should try to get the call for papers open relatively soon, and I hope we get a lot of people in there, and also that will hopefully bring some money for the foundation. And
what was the original, like when did you decide this, we need to have a conference on this? Like what was kind of the motivation behind that?
There was a lot of people were asking about it, and we noticed that, we have community. I think it actually went so that we started running meetups.
Gotcha.
Around the world, but especially in Helsinki. And then when we had a meetup where we suddenly had 80 people in, I figured that, we could instead have a conference, because 80 people would be already a kind of decent conference size, so why not? And then that's how basically it started, and then we ran it, and I think we had 250 or 300 or something like that in the first installment, and then it's been increasing a bit, so I think it was 350 or something like that last January.
Got it.
So it's been nice. Being based in Helsinki, so of course it's kind of far for people from the US, but we've had, I think, every time like a dozen people from the States as well, and also around the world. So that's been awesome. Of course, a lot of people from Finland, from Helsinki, where it's been organized, and a lot of people from around the Europe, which is obviously kind of like 2 or 3 hour plane flight away compared to US. That is much more. So is the people to participate. But the great thing with the online conference that we now planning to organize, we actually already have made a plan that we are going to do it. The great thing, of course, it's easy for people around the world to participate.
Right.
They're both as a presenter and also as participants. So it's going to be interesting to see when we open the CFP how many proposals we are going to get. I would expect we got even more than for the earlier on-site conferences.
Gotcha.
So that's going to be great, and I think that if it goes at all well, we are going to keep running them, even if we hopefully in the future sometime can also again organize an on-site event. And
I very much sympathize with you on that, and I wish you all the success with the virtual conference. And I keep hearing that there's that additional reach with the virtual conference, and like Jason Lance was saying that about their open source sprints. They've had to go virtual. They're thinking about keeping a virtual layer on them, even if they go back in real life events. I also think Jason would thank you actually for having it in Helsinki in January, because apparently U.S. flights to Helsinki in January are surprisingly cheap. And that's our show. Now, we will have links to both the Robot Framework and the Robot Framework Foundation in the show notes for this episode if you would like to check them out. Now, before we go, I did ask after Pekka's favorite non-technical hobby, and it turns out Finland's really good for skiing.
Well, we're living in southern Finland, so not big hills, but something. It's fun that you can. I mean, I've been doing even like park, like little jumps and rails and stuff like that. So all that. So that's okay in small hills even. But then we have some decent opportunities if you go to north of Finland, Lapland. Like I especially like off-piste telemark skiing. That's one of my really like favorite. Then I have kids, which is kind of I don't know, it takes enough of the free time, so that you don't have that much problems like having extra hobbies.
I want to thank Pekka for the great conversation and information. And of course, as always, I want to thank you for listening. Now, if you want to learn more about this show, head on over to developer.salesforce.com/podcast, where you can hear old episodes, see the show notes, and have links to your favorite podcast service. I'll talk to you next week.